Hi everyone, welcome back to Chemistry Coaching by Michelle. In this video, I will share with you the topic on electrolysis using inert electrode. Inert means unreactive electrode. What is electrolysis? It's a process which decomposes a compound in the electrolyte solution, either in molten or aqueous state. So, how to set up an electrolytic cell? An electrolytic cell is made up of two electrodes, a positive and a negative electrode. Electrolyte solution, which is usually molten ionic compound or aqueous solution. And lastly, power supply, which is the battery. The electrode is usually a rod or a metal plate which is conductor of electricity, for example, graphite or platinum. The electrode which is joined to the positive terminal of the battery is known as anode, the positive electrode, and is where the negative ion and anion will get attracted and oxidation take place at positive anode where the anion give up electron. While for cathode, which is joined to the negative terminal of a battery, is a negative electrode. Is where positive ion, cation, is attracted and reduction process take place at cathode where the cation gain electron. How about for electrolyte solution? The electrolyte solution is usually molten ionic compound or aqueous solution, which decompose to form positive ion and negative ion. For example, when molten sodium chloride is used, it gets broken down into Na plus and Cl minus ion. Similarly, when aqueous HCl is used, it gets broken down into H plus and Cl minus, and on top of that, we also have the hydroxide ion from the aqueous solution. And how about for copper sulfate solution? It will get broken down into Cu2 plus, SO42 minus, and on top of that, we have H plus and OH minus from the decomposition of water in aqueous solution. Scenario 1. Molten ionic compound, lead bromide, is used as electrolyte. It decomposes into lead 2 plus ion and bromide ion, Br minus. At anode, the positive electrode, the bromide ion is oxidized and bromine gas is formed. While at cathode, the negative electrode, the lead 2 plus ion is reduced and molten lead is formed. What happens when aqueous solution is used? For example, when aqueous PbBr2 is used, besides Pb2 plus and Br minus ion, we also have water in aqueous solution which will be broken down into H plus and OH minus ion. The tricky part is here. Which ion will be selectively discharged at anode? Should it be Br minus or OH minus? How about the cathode? Should it be lead 2 plus ion or H plus ion? Well, the ion that are selectively discharged in aqueous solution depends on the position in the reactivity series. The less reactive metal, which means the ion which is found at the lower part of the reactivity series, will be preferentially discharged. For example, when both Na plus and H plus ion are present, H plus ion is preferentially discharged because it's found at the lower part of the series. Similarly, for anion, when both NO3 minus and OH minus are present, do you think which ion will be selectively discharged? Again, OH minus, which is positioned at the bottom part of the series, will get preferentially discharged over the NO3 minus. So let's back to our electrolyte solution using PbBr2. So in this case, for anode, it will be the OH minus get selected as the position of the OH minus is at the bottom of the series. Similarly for cathode, it will be the H plus ion. However, when concentrated electrolyte solution is used, The ion that are selectively discharged depends on, for negative ion, the ion which is in higher concentration will be preferentially discharged. But not for sulfate and nitrate ion, as both of them will never get discharged during electrolysis solution. How about for positive ion? The positive ion are not get affected by the concentration of the electrolyte solution. Let's have a look on this example here. Earlier on, we have the electrolysis using dilute lead bromide solution. So we have this comparison between the dilute solution versus the concentrated solution. So my question to you, at anode, which ion will get preferentially discharged? Should it be OH minus or Br minus? If you remember earlier on, the negative ion will always get affected by the concentration of the solution. So in concentrated PbBr2 solution, the amount of Br minus is much more than the OH minus. Hence, Br minus is preferentially discharged over OH minus. How about at cathode? As the concentration does not affect the selection of the positive ion, hence both of the reaction, the H plus will get selected. That's all for today's video. I will see you in next video on electrolysis using reactive electrode. Thank you. Bye.